Okay, so I'm going to work an example for you from chapter 7. This is from your dashboard assignment, level 2, 7E exercises, and this is number 12. You get a lot of questions like this. So it says, create a truth table and then determine whether the following is contingent, a tautology, or a self-contradiction. All right, so the first thing, and here's the statement that you're given, the formula. Now, the first thing I want to do is set up my truth table, okay? So I have two columns at the beginning here because I have two, basic terms, elementary statements. They're P and Q, okay? And then I've got my statement, the full formula laid out here, and I left a column under each one because each one of these is going to have a truth value. All right, now the whole idea of a truth table is that you just set it up in this mechanical way that gives you all possible combinations of the truth values of the basic elementary statements, right? So, this statement P, it might be true and it might be false. So we're going to have, and by the way, the number of lines is like the number of elementary statements raised to the, it's 2 raised to the number of, there's a way, this, I said it somewhere else, I can't remember. All I know is this is, it's 2 raised to the power of the number of basic elementary statements that there are. So 2 raised to the second power is 4, okay? So we got true, true, false, false, and then this could be true, false, okay? Now, those are all your combinations of what P and Q might be. Let me even just make these colors so that you can tell. Now, we want to go and first of all assign truth values to the basic statements, and then we work towards the higher level logical operators. All right. So let me start with P in this statement. Now, we've already worked out the possible combinations of truth values for P. So what I can do is just copy that and do the exact same thing under here. What about not P? What are the truth values for not P? Well, that's an easy one too. It's just going to be the opposite of whatever we put in the P column, right? So if P is true, then not P is false. And if P is false, then not P is true. Okay, so now we've dealt with the not P. What about Q? Well, once again, we've already worked out the Q column. Let me just cut and paste that here. All right, now what we want to do, I left out some really important parentheses here. That's important. Okay. Now, we want to deal with everything that's inside the parentheses. Okay, so we want to deal with this conjunction sign and its truth values. Now, by just looking and thinking for a second about this part of the statement, P and not P, we already know that the truth value for the conjunction sign is going to be false all the way down, because there's no case in which both P and not P can be true at the same time. And as a matter of fact, when we look at it, the truth conditions for a conjunction are both of the conjuncts, both the things on both sides of the and have to be true. Well, it's not true here. This one's false. This one's false here. I'm sorry, that's the opposite. It should be false. False, false, false. Okay. Now, let's think about our or statement. The truth conditions for an or statement, and this is the main operator right here. Okay, this is the most important column. The truth condition for an or statement is that at least one of the disjuncts has to be true. So we can even just look at our Q statement, and what we're comparing here is, pardon me, this column, because the conjunction here is the main operator of this parenthetical part. We want to compare the truth values of the conjunction with the truth values of Q. That's what we're comparing. And what we come up with in the middle here is the truth values of the whole statement. Now, here, stop. So here, the Q is true. So this is going to be true. But this line here, they're both false. We got false over here, false over here. So that's false. False over here, but true here, so it's true. And then they're both false here. So that's false. So this column under the main operator gives us the truth values of the whole statement. All right, so we created a truth table. Now our question is this: how do we use this truth table to determine whether or not the entire statement is contingent or a tautology or a self-contradiction? Well, here's the basic key. We're going to look at the column under the main operator, all right? If the whole statement is contingently true, that means that some but not all of the lines under that main operator are true. And that's exactly what we've got here. So this statement is going to be contingent. A tautology would have all of the lines under the main operator as true. That's not what we got here. A self-contradiction would have all of the lines under the main operator as false. We've got a mix, so it's a contingent statement.